Hi everyone, welcome back to another exciting chemistry video. Have you ever wondered how scientists balance nuclear reaction just like chemical reaction? Have you also wondered the steps that scientists use in balancing nuclear reaction? Now, in this video, I'm going to be teaching you how to balance nuclear reaction like a pro, giving you the easy step so that at the end of this video, you should be able to balance nuclear reaction with ease. My name remains Adrenaline, the Bazooka Prophet, CEO Adrenaline Tutorial Online Platform, a platform that have helped students around the world master sciences. Now, we move ahead in the balancing. We should understand that there are some basic steps that should be undertaken in the sense that in the case of nuclear reaction, an element is transformed to another element by the emission of alpha decay, beta decay, and neutron, proton as the case. All these are particles that are involved in nuclear reactions. Now, understand it. It is not like chemical reactions that involve the rearrangement of electrons of an element. In nuclear reaction, an element is transformed to another element. For example, we go ahead in solving questions from O level and A level questions. The first question says, an atom Q having mass number 234, atomic number 88 decays by alpha emission to give an atom R. The atomic number and mass number of atom R are respectively what? Now we go ahead to solve the first question. Now take note, Q, which has a mass number of 234, atomic number of 88, they've already told you that it decays by the emission of alpha particle. Now take note, these are some of the particles you use. These are some of the decays. What we call alpha. Take note, an alpha particle is an helium nucleus having a mass number of 4, atomic number of 2. We have beta decay. Beta decay is 0 minus 1, also called negatron. We can also have positron. In the case of positron, positron is 0 and plus 1. We can also have neutrons. Neutrons is also a particle. We can also have proton. Proton is like this. All these are the particles that are involved in nuclear reaction balancing. Now, please take note, the balancing of nuclear reaction and chemical reaction are the same, in which there is what we call the law of conservation of mass is obeyed. Do not forget that in an hurry. So we continue in this travail. Meanwhile, please take note of these particles. Okay. Now we go deeper. Understand. Now they said alpha, meaning in place of alpha now, we'll put this helium nucleus 4 and what now 2 plus you have your arrow here. Remember, this your arrow here, they're asking you for the atomic number and mass number. Take note, mass number is written as a superscript, meaning it is always at the top. Atomic number is written as a subscript, meaning it is always at the bottom. So what do? Both the left and the right must be balanced in terms of their mass number and in terms of their atomic what number. So we go with the mass number first. 234, this sign here means equal to, follow my step please, it's actually very easy. You have your mass number A here plus atomic number here is 4, right? So if I'm looking for my mass number A is now equal to 234 minus 4. A is now equal to 230. So that is for the mass number. meaning both the mass number of the reactant and that of the product must be equal. So 230 plus 4 is 234, which is equal to what we have in the left hand side. Very easy, right? I know. So watch out for the next step I'm to go through now. Now, please take note. This is for atomic number, mass number, right? We'll move to the atomic number now. We have 88 here, again equal to, I'm having Z here, plus 2. Now take note, atomic number here, which is Z, is now equal to 88. When plus 2 crosses this step, it turns to minus 2, which is now equal to what now? 86. So the atomic number of arrow is 86, but the mass number of arrow is 230. I hope that is all right. So quickly, we are done with the first question. We now move quickly to the question 2. The same procedure and processes will still be obeyed. Now, let's go. Now, I erase the board. Actually, I erase the board. So we continue. Now, in the case of question 2, this is thorium. This is palladium. So what do I do? I'm having thorium here, having 234. I'm having 90 at the atomic number. When it decays, it releases beta plus palladium. Here is Y and here is X. They are asking you for Y and X, which is the mass number is the Y, atomic number is the X. Now, listen. They didn't label here for you, but you on your own, you understand the rudiment of it. That the top here, for this is a beta particle, and a beta particle has the mass number of 0 and the atomic number of -1. The same rule applies. The right and the left must be balanced, obeying the law of the conservation of mass and also the conservation of what atomic number in this case. Now, 234 here, remember the mass number of beta is 0. So it means that Y here will still be 234. Why? 234 plus 0 is also 234. So Y here is already 234. Now, in the case of atomic number here, 90 is equal to X minus 1, right? So when X becomes 90, minus 1 crosses it turns to plus 1. The final answer is 91. So that 91 minus 1 is equal to 90. Now, this is how to balance questions under nuclear reaction. We'll move to the next one to actually talk deeper on some other corny questions. For now, this is the end of this video. Thank you and God bless you.